declared explicitly with Java or XML, discovered by component scanning, or automatically configured with Spring Boot auto-configurations. Chapter 2. Developing Web Applications. This chapter covers presenting model data in the browser, processing and validating form input, choosing a view template library. First impressions are important. Curb appeal can sell a house long before the home buyer enters the door. A car's cherry red paint job will turn more heads than what's under the hood. And literature is replete with stories of love at first sight. What's inside is important, but what's outside, what's seen first, is also important. The applications you build with Spring will do all kinds of things, including crunching data, reading information from a database, and interacting with other applications. But the first impression your application users will get comes from the user interface. And in many applications, that UI is a web application presented in a browser. In Chapter 1, you created your first Spring MVC controller to display your application homepage. But Spring MVC can do far more than simply display static content. In this chapter, you'll develop the first major bit of functionality in your Taco Cloud application, the ability to design custom tacos. In doing so, you'll dig deeper into Spring MVC, and you'll see how to display model data and process form input. Section 2.1. Displaying information. Fundamentally, Taco Cloud is a place where you can order tacos online. But more than that, Taco Cloud wants to enable its customers to express their creative side and design custom tacos from a rich palette of ingredients. Therefore, the Taco Cloud web application needs a page that displays the selection of ingredients for taco artists to choose from. The ingredient choices may change at any time, so they shouldn't be hard-coded into an HTML page. Rather, the list of available ingredients should be fetched from a database and handed over to the page to be displayed to the customer. In a Spring web application, it's a controller's job to fetch and process data, and it's a view's job to render that data into HTML that will be displayed in the browser. You're going to create the following components in support of the taco creation page. A domain class that defines the properties of a taco ingredient. A Spring MVC controller class that fetches ingredient information and passes it along to the view. A view template that renders a list of ingredients in the user's browser. The relationship between these components is illustrated in Figure 2.1. Because this chapter focuses on Spring's web framework, we'll defer any of the database stuff to Chapter 3. For now, the controller is solely responsible for providing the ingredients to the view. In Chapter 3, you'll rework the controller to collaborate with a repository that fetches ingredients data from a database. Before you write the controller and view, let's hammer out the domain type that represents an ingredient. This will establish a foundation on which you can develop your web components. Section 2.1.1. Establishing the domain. An application's domain is the subject area that it addresses, the ideas and concepts that influence the understanding of the application. In the Taco Cloud application, the domain includes such objects as taco designs, the ingredients that those designs are composed of, customers, and taco orders placed by the customers. Figure 2.2 shows these entities and how they are related. Footnote 1. For a much more in-depth discussion of application domains, I suggest Eric Evans' Domain-Driven Design. In your domain, taco ingredients are fairly simple objects. Each has a name as well as a type so that it can be visually categorized: proteins, cheeses, sauces, and so on. Each also has an ID by which it can easily and unambiguously be referenced. The following ingredient class defines the domain object you need. As you can see, this is a run-of-the-mill Java domain class, defining the 3 properties needed to describe an ingredient. Perhaps the most unusual thing about the ingredient class as defined in Listing 2.1 is that it seems to be missing the usual set of getter and setter methods, not to mention useful methods like equals, hashcode, toString, and others. You don't see them in the listing partly to save space, but also because you're using an amazing library called Lombok to automatically generate those methods at compile time, so that they will be available at runtime. In fact, the @data annotation at the class level is provided by Lombok, and tells Lombok to generate all of those missing methods, as well as a constructor that accepts all final properties as arguments. By using Lombok, you can keep the code for ingredient slim and trim. Lombok isn't a Spring library, but it's so incredibly useful that I find it hard to develop without it. Plus, it's a lifesaver when I need to keep code examples in a book short and sweet. To use Lombok, you'll need to add it as a dependency in your project. If you're using Spring Tool Suite, it's an easy matter of right-clicking on the pom.xml file and selecting Add Starters from the Spring context menu. The same selection of dependencies you were given in Chapter 1, in Figure 1.4, will appear, giving you a chance to add or change your selected dependencies. Find Lombok under Developer Tools. Make sure it's selected and click OK. Spring Tool Suite automatically adds it to your build specification. Alternatively, you can manually add it with the following entry in pom.xml. If you decide to manually add Lombok to your build, you'll also want to exclude it from the Spring Boot Maven plugin in the Build section of the pom.xml file. Lombok's magic is applied at compile time, so there's no need for it to be available at runtime. Excluding it like this keeps it out of the resulting jar or WAR file. The Lombok dependency provides you with Lombok annotations, such as @data, at development time, and with automatic method generation at compile time. But you'll also need to add Lombok as an extension in your IDE, or your IDE will complain, with errors about missing methods and final properties that aren't being set. Visit this link to find out how to install Lombok in your IDE of choice. Why are there so many errors in my code? It bears repeating that when using Lombok, you must install the Lombok plugin into your IDE. Without it, your IDE won't be aware that Lombok is providing getters, setters, and other methods, and will complain that they are missing. Lombok is supported in a number of popular IDEs, including Eclipse, Spring Tool Suite, IntelliJ IDEA, and Visual Studio Code. Visit this link for more information on how to install the Lombok plugin into your IDE. I think you'll find Lombok to be very useful, but know that it's optional. You don't need it to develop Spring applications, so if you'd rather not use it, feel free to write those missing methods by hand. Go ahead, I'll wait. Ingredients are the essential building blocks of a taco. To capture how those ingredients are brought together, we'll define the taco domain class, as shown next. As you can see, taco is a straightforward Java domain object with a couple of properties. Like ingredient, the taco class is annotated with @data to have Lombok automatically generate essential Java Bean methods for you at compile time. Now that we have defined ingredient and taco, we need one more domain class that defines how customers specify the tacos that they want to order, along with payment and delivery information. That's the job of the taco order class, shown here. Aside from having more properties than either ingredient or taco, there's nothing particularly new to discuss about taco order. It's a simple domain class with 9 properties. 5 for delivery information, 3 for payment information, and 1 that is the list of taco objects that make up the order. There's also an add taco method that's added for the convenience of adding tacos to the order. Now that the domain types are defined, we're ready to put them to work. Let's add a few controllers to handle web requests in the application. Section 2.1.2, Creating a Controller Class. Controllers are the major players in Spring's MVC framework. Their primary job is to handle HTTP requests and either hand off a request to a view to render HTML, browser displayed, or write data directly to the body of a response, RESTful. In this chapter, we're focusing on the kinds of controllers that use views to produce content for web browsers. When we get to Chapter 7, we'll look at writing controllers that handle requests in a REST API. For the Taco Cloud application, you need a simple controller that will do the following. Handle HTTP GET requests where the request path is /design. Build a list of ingredients. Hand off the request and the ingredient data to a view template to be rendered as HTML and sent to the requesting web browser. The Design Taco Controller class in the next listing addresses those requirements. The first thing to note about Design Taco Controller is the set of annotations applied at the class level. The first, at SLF4J, is a Lombok-provided annotation that, at compilation time, will automatically generate an SLF4J, Simple Logging Facade for Java, see this link, logger static property in the class. This modest annotation has the same effect as if you were to explicitly add the following lines within the class. You'll make use of this logger a little later. The next annotation applied to Design Taco Controller is @controller. This annotation serves to identify this class as a controller and to mark it as a candidate for component scanning, so that Spring will discover it and automatically create an instance of Design Taco Controller as a bean in the Spring application context. Design Taco Controller is also annotated with @request mapping. The @request mapping annotation, when applied at the class level, specifies the kind of requests that this controller handles. In this case, it specifies that Design Taco Controller will handle requests whose path begins with /design. Finally, you see that Design Taco Controller is annotated with @session attributes, taco order. This indicates that the taco order object that is put into the model a little later in the class should be maintained in session. This is important because the creation of a taco is also the first step in creating an order, and the order we create will need to be carried in the session so that it can span multiple requests. Handling a GET request. The class-level @request mapping specification is refined with the @getMapping annotation that adorns the showDesignForm method. @getMapping, paired with the class-level @request mapping, specifies that when an HTTP GET request is received for /design, Spring MVC will call showDesignForm to handle the request. @getMapping is just one member of a family of request mapping annotations. Table 2.1 lists all of the request mapping annotations available in Spring MVC. When showDesignForm handles a GET request for /design, it doesn't really do much. The main thing it does is return a string value of design, which is the logical name of the view that will be used to render the model to the browser. But before it does that, it also populates the given model with an empty taco object under a key whose name is design. This will enable the form to have a blank slate on which to create a taco masterpiece. It would seem that a GET request to /design doesn't do much, but on the contrary, there's a bit more involved than what is found in the showDesignForm method. You'll also notice a method named addIngredientsToModel that is annotated with @modelAttribute. This method will also be invoked when a request is handled, and will construct a list of ingredient objects to be put into the model. The list is hard-coded for now. When we get to Chapter 3, you'll pull the list of available taco ingredients from a database. Once the list of ingredients is ready, the next few lines of addIngredientsToModel filters the list by ingredient type using a helper method named filterByType. A list of ingredient types is then added as an attribute to the model object that will be passed into showDesignForm. Model is an object that ferries data between a controller and whatever view is charged with rendering that data. Ultimately, data that's placed in model attributes is copied into the servlet request attributes, where the view can find them and use them to render a page in the user's browser. Following addIngredientsToModel are two more methods that are also annotated with @modelAttribute. These methods are much simpler and create only a new taco order and taco object to place into the model. The taco order object, referred to earlier in the @session attributes annotation, holds state for the order being built as the user creates tacos across multiple requests. The taco object is placed into the model so that the view rendered in response to the GET request for /design will have a non-null object to display. Your Design Taco controller is really starting to take shape. If you were to run the application now and point your browser at the /design path, the Design Taco Controller's Show Design form and Add Ingredients to Model would be engaged, placing ingredients and an empty taco into the model before passing the request on to the view. But because you haven't defined the view yet, the request would take a horrible turn, resulting in an HTTP 500 internal server error. To fix that, let's switch our attention to the view where the data will be decorated with HTML to be presented in the user's web browser. Section 2.1.3 Designing the View. After the controller is finished with his work, it's time for the view to get going. Spring offers several great options for defining views, including Java Server Pages, JSP, TimeLeaf, FreeMarker, Mustache, and Groovy-based templates. For now, we'll use TimeLeaf, the choice we made in Chapter 1 when starting the project. We'll consider a few of the other options in Section 2.5. We have already added TimeLeaf as a dependency in Chapter 1. At runtime, Spring Boot auto-configuration sees that TimeLeaf is in the class path and automatically creates the beans that support TimeLeaf views for Spring MVC. View libraries, such as TimeLeaf, are designed to be decoupled from any particular web framework. As such, they're unaware of Spring's model abstraction and are unable to work with the data that the controller places in model. But they can work with servlet request attributes. Therefore, before Spring hands the request over to a view, it copies the model data into request attributes that TimeLeaf and other view templating options have ready access to. TimeLeaf templates are just HTML with some additional element attributes that guide a template in rendering request data. For example, if there were a request attribute whose key is message and you wanted it to be rendered into an HTML p tag by TimeLeaf, you'd write the following in your TimeLeaf template. When the template is rendered into HTML, the body of the p tag element will be replaced with the value of the servlet request attribute whose key is message. The th:\text attribute is a TimeLeaf namespace attribute that performs the replacement. The $braces operator tells it to use the value of a request attribute, message in this case. TimeLeaf also offers another attribute, th:\each, that iterates over a collection of elements, rendering the HTML once for each item in the collection. This attribute will come in handy as you design your view to list taco ingredients from the model. For example, to render just a list of wrap ingredients, you can use the following snippet of HTML. Here you use the th:\each attribute on the div tag to repeat rendering of the div tag once for each item in the collection found in the wrap request attribute. On each iteration, the ingredient item is bound to a TimeLeaf variable named ingredient. Inside the div tag element are a checkbox input tag element and a span tag element to provide a label for the checkbox. The checkbox uses TimeLeaf's th:\value to set the rendered input tag element's value attribute to the value found in the ingredient's ID property. The th:\field attribute ultimately sets the input tag element's name attribute and is used to remember whether or not the checkbox is checked. When we add validation later, this will ensure that the checkbox maintains its state should the form need to be redisplayed after a validation error. The span element tag uses th:\text to replace the ingredient placeholder text with the value of the ingredient's name property. When rendered with actual model data, one iteration of that div tag loop might look like this. Ultimately, the preceding TimeLeaf snippet is just part of a larger HTML form through which your taco artist users will submit their tasty creations. The complete TimeLeaf template, including all ingredient types and the form, is shown in the following listing. As you can see, you repeat the div tag snippet for each of the types of ingredients, and you include a submit button and field where the user can name their creation. It's also worth noting that the complete template includes the Taco Cloud logo image and a link tag reference to a style sheet. In both cases, TimeLeaf's @braces operator is used to produce a context-relative path to the static artifacts that these tags are referencing. As you learned in Chapter 1, Static content in a Spring Boot application is served from the /static directory at the root of the class path. Footnote 2. The contents of the style sheet aren't relevant to our discussion. It contains only styling to present the ingredients in 2 columns instead of one long list of ingredients. Now that your controller and view are complete, you can fire up the application to see the fruits of your labor. We have many ways to run a Spring Boot application. In Chapter 1, I showed you how to run the application by clicking the Start button in the Spring Boot dashboard. No matter how you fire up the Taco Cloud application, once it starts, point your browser to http://localhost:8080/design. You should see a page that looks something like Figure 2.3. It's looking good. A taco artist visiting your site is presented with a form containing a palette of taco ingredients from which they can create their masterpiece. But what happens when they click the Submit Your Taco button? Your Design Taco controller isn't yet ready to accept taco creations. If the design form is submitted, the user will be presented with an error. Specifically, it will be an HTTP 405 error, request method post not supported. Let's fix that by writing some more controller code that handles form submission. Section 2.2. Processing form submission. If you take another look at the form tag in your view, you can see that its method attribute is set to post. Moreover, the form doesn't declare an action attribute. This means that when the form is submitted, the browser will gather all the data in the form and send it to the server in an HTTP post request to the same path for which a GET request displayed the form, the /design path. Therefore, you need a controller handler method on the receiving end of that post request. You need to write a new handler method in Design Taco Controller that handles a post request for /design. In Listing 2.4, you used the @getMapping annotation to specify that the showDesignForm method should handle HTTP GET requests for /design. Just like @getMapping handles GET requests, you can use @postMapping to handle post requests. For handling taco design submissions, add the Process Taco method in the following listing to Design Taco Controller. As applied to the Process Taco method, @postMapping coordinates with the class level @requestMapping to indicate that Process Taco should handle post requests for /design. This is precisely what you need to process a taco artist's submitted creations. When the form is submitted, the fields in the form are bound to properties of a taco object, whose class is shown in the next listing, that's passed as a parameter into Process Taco. From there, the Process Taco method can do whatever it wants with the taco object. In this case, it adds the taco to the taco order object passed as a parameter to the method and then logs it. The @model attribute applied to the taco order parameter indicates that it should use the taco order object that was placed into the model via the @model attribute annotated order method shown earlier in Listing 2.4. If you look back at the form in Listing 2.5, you'll see several checkbox elements, all with the name Ingredients, and a text input element named Name. Those fields in the form correspond directly to the ingredients and name properties of the taco class. The name field on the form needs to capture only a simple textual value. Thus, the name property of taco is of type string. The ingredients checkboxes also have textual values, but because 0 or many of them may be selected, the ingredients property that they're bound to is a list ingredient that will capture each of the chosen ingredients. But wait, if the ingredients checkboxes have textual, for example, string values, but the taco object represents a list of ingredients as list ingredients, then isn't there a mismatch? How can a textual list like an array of strings FLTO, GRBF, LETC be bound to a list of ingredient objects that are richer objects containing not only an ID, but also a descriptive name and ingredient type? That's where a converter comes in handy. A converter is any class that implements Spring's converter interface and implements its convert method to take one value and convert it to another. To convert a string to an ingredient, we'll use the ingredient by ID converter as follows. Because we don't yet have a database from which to pull ingredient objects, the constructor of ingredient by ID converter creates a map keyed on the string that is the ingredient ID and whose values are ingredient objects. In Chapter 3, we'll adapt this converter to pull the ingredient data from a database instead of being hard-coded like this. The convert method then simply takes a string that is the ingredient ID and uses it to look up the ingredient from the map. Notice that the ingredient by ID converter is annotated with @component to make it discoverable as a bean in the Spring application context. Spring Boot auto configuration will discover this and any other converter beans, and will automatically register them with Spring MVC to be used when the conversion of request parameters to bound properties is needed. For now, the process taco method does nothing with the taco object. In fact, it doesn't do much of anything at all. That's okay. In Chapter 3, you'll add some persistence logic that will save the submitted taco to a database. Just as with the showDesignForm method, process taco finishes by returning a string value. And just like showDesignForm, the value returned indicates a view that will be shown to the user. But what's different is that the value returned from process taco is prefixed with redirect, indicating that this is a redirect view. More specifically, it indicates that after process taco completes, the user's browser should be redirected to the relative path /orders/current. The idea is that after creating a taco, the user will be redirected to an order form from which they can place an order to have their taco creations delivered. But you don't yet have a controller that will handle a request for /orders/current. Given what you now know about @controller, @request mapping, and @get mapping, you can easily create such a controller. It might look something like the following listing. Once again, you use Lombok's @slf4j annotation to create a free slf4j logger object at compile time. You'll use this logger in a moment to log the details of the order that's submitted. The class level @request mapping specifies that any request handling methods in this controller will handle requests whose path begins with /orders. When combined with the method level @get mapping, it specifies that the order form method will handle HTTP GET requests for /orders/current. As for the order form method itself, it's extremely basic, only returning a logical view name of order form. Once you have a way to persist taco creations to a database in Chapter 3, you'll revisit this method and modify it to populate the model with a list of taco objects to be placed in the order. The order form view is provided by a time-leaf template named orderform.html, which is shown next. For the most part, the orderform.html view is typical HTML/timeleaf content, with very little of note. It starts by listing the tacos that were added to the order. It uses timeleaf's th:\each to cycle through the order's tacos property as it creates the list. Then it renders the order form. But notice that the form tag here is different from the form tag used in listing 2.5, in that it also specifies a form action. Without an action specified, the form would submit an HTTP POST request back to the same URL that presented the form. But here, you specify that the form should be posted to /orders, using timeleaf's @braces operator for a context-relative path. Therefore, you're going to need to add another method to your order controller class that handles post requests for /orders. You won't have a way to persist orders until the next chapter, so you'll keep it simple here. Something like what you see in the next listing. When the process order method is called to handle a submitted order, it's given a taco order object whose properties are bound to the submitted form fields. Taco order, much like taco, is a fairly straightforward class that carries order information. In the case of this process order method, the taco order object is simply logged. We'll see how to persist it to a database in the next chapter. But before process order is done, it also calls setComplete on the session status object passed in as a parameter. The taco order object was initially created and placed into the session when the user created their first taco. By calling setComplete, we are ensuring that the session is cleaned up and ready for a new order the next time the user creates a taco. Now that you've developed an order controller and the order form view, you're ready to try it out. Open your browser to http://localhost:8080/design. Select some ingredients for your taco and click the Submit Your Taco button. You should see a form similar to what's shown in Figure 2.4. Fill in some fields in the form and press the Submit Order button. As you do, keep an eye on the application logs to see your order information. When I tried it, the log entry looked something like this, reformatted to fit the width of this page. It appears that the process order method did its job, handling the form submission by logging details about the order. But if you look carefully at the log entry from my test order, you can see that it let a little bit of bad information get in. Most of the fields in the form contained data that couldn't possibly be correct. Let's add some validation to ensure that the data provided at least resembles the kind of information required. Section 2.3. Validating Form Input.